Using the appropriate equation, show how electric force between two charges, the electric field intensity, and the electric potential are related. Very simple and so we have two things there. Welcome to my class, Mr. Bam's online class. How you doing? Hope you are good. Now listen, this is from electric field, from Coulombs Law of Charges. Then under it we have this electric force between the two charges. Then we have the electric field intensity E, you understand now, in that field, of that field, and then we have the electric potential V. So how are they related? So we have three things here. We have the force F between the two charges. We have the electric field intensity E, you understand, the strength of that field, and then the electric potential. Now, first and foremost, let me explain one or two things there for you. Don't forget the Coulombs Law of Charges. Coulombs Law of Charges states that the force of attraction or repulsion between two charges is directly proportional to the product of the two charges and inversely proportional to the square of the distance apart. Let's say we have two charges in the field. We have two charges, plus and minus. You understand me now? In a field, this is the field here. You understand me now? Two charges. Now, let's say the two charges are separated by a distance r. You know, of course, these are unlike charges. They are different and they always attract. You understand me now? If it is plus plus, that is like charge, they will repel. That's why the law states that the force of attraction or repulsion. So that force is F now, force F. So this is the two charges. I can say the first one is Q1, second charge is Q2. We have two charges Q1, Q2, separated by a distance R, where the force of attraction is F. Notice. So that force is my F here. Understood now? Now the strength of this field, the strength is my E. It's called electric field intensity, the strength of that field. Why my V? Listen, V is called electric potential. There are two different types of electric potential. The first one is electric potential at a point from infinity. You understand me now? And the second one is the electric potential between 2 points. Let's say between two charges. But the one we are talking about here is between two charges. Understood now? Now that electric potential is the work done in moving the charge from one point to another. The work done in moving this charge from here to here, or this charge from here to here. That work done is called my electric potential. While my E is the strength of that field. While my F, of course, is the force of attraction or repulsion between the two charges. So how are the three parameters? How are they related? That's what we are talking about. Okay, let's quickly say, now let me start with F from Coulomb Law of Charges. It says that the force of attraction between two charges, Q1, Q2, that force F, this force F, varies directly to the what? Product of the charges, Q1 times Q2. And the same force varies inversely to the square of the distance apart. Note it. You understand that? Note that. So which means that my F equals to what? Equals to K. K is my constant. K, constant. So I have K times what? Q1, Q2 all over R squared. You understand me now? Okay. So which means that I know, don't forget that my K is what? My K is, don't forget, is 1. Normally you'll be given in your question. You understand that? And if you are not given, you have to know it often. Your K is called electric constant. You understand me now? Note it. You understand me now? Electric constant. Notice. So my K is my 1 over 4 pi, 1 over 4 pi permittivity naught. That's what my K stands for. Notice. They would have given you, understand me now? And if they are not giving you have to know it offhand. This E naught is called permittivity of free space. Permittivity of free space. Of course, you know what your pi means and your 4. So everything is a constant called K. You understand me now? That we put here. You understand me now? So note it. Noted. So now, if I put my K here, so it's going to become what? F equals to what? My K is 1 over 4 pi E naught, then times what? Times Q1, Q2 all over R squared. You see now? So from there, I'm going to have my K. From there, my F equals to what now? My F equals to, if I multiply this and that, that's what? That's Q1, Q2 all over 4 pi E naught R squared. So that's my first one, equation 1. I've got my formula F here. That's the formula. Q1, Q2 all over 4 pi E naught R squared. That's for F. Now, second one is my electric field intensity. Electric field intensity at the point is equals to F over Q over unit positive charge. F over Q. Note it. You understand me now? F over Q. Note it. So what will I do? I will just bring in my F. Don't forget that my F is already all this. So I'll just come to this formula. Let me call it equation 2. I'll just come here. Anywhere I see F, I remove and put all this one to stand as my F here. You understand me now? Now, you know this Q1, Q2. I can call it Q2 or Q1, anyone. Understand me now? Q1, it can be any of those Q. Anyone there. Or you can just call it capital Q, small q. It depends on what you are using. Let me use capital Q, small q. You understand me now? It can be anything. Capital Q, small q. But I can use small q here. You understand me now? Now, let me now substitute everything I have here as my F into this place now. Let's see. So from there, let me clean it. From there, let me clean it. So from there, I'm going to have what? I'm going to have this. So my E equals to what? My F is everything here. That's Q all over 4 pi E naught R squared, all divided by Q. And if we divide by Q, that means you multiply by 1 over Q if you swap it back. Divided by Q means times 1 over Q. Understand me now? Note you put a 1 all over that Q. And Q cancel Q. So Q E equals to what? Q all over 4 pi E naught R. This is the second formula. This is the first formula. This is the second formula. You can see how F and Q are related. You can see they are having similar, parameters there. You understand that? That's the second one. Now, third one is my electric field, what's called electric potential V. Now, the formula you're going to use, E equals to V equals to ER. This is the formula for electric potential V. V equals to ER. So your V, you multiply your electric field intensity, like got here, by your distance R apart. So note it. From there, V equals to what? What's my E? I'll just put in my E here. So that's my E is Q all over 4 pi E naught R squared times R. See now? So 1 R cancels 1 R here, cancels this. So my V equals to what? Q all over 4 pi E naught R. Is it R there? 4 pi E naught R. So this is my V. So that's what I'm asked to do. So that is how my F, my E, and my V are related. They are also related by this formula also, this simple formula here. So if you are given any question, you have to look at the parameters that you are given in that question closely in order to know the formula that you are going to use for it. Understood? So very easy and simple. Hope you have gotten one or two things there. Don't forget that each of all these parameters, they have their own units. Okay, let me put their units. What was the unit of Q? Of course, Q is the charge. Charge is measured in coulombs. Both Q and Q are in coulombs. That's for Q. And my R is my distance in meters. My R is my distance in meter. You understand me now? So note it. All these are constants. Understand me now? All these are constant. Note it. Understand? Now my F is in what? Is in Newton. My F is my force, of course, in what? In Newton. What again? My E is my electric field intensity. From this formula, E equals F over Q. That's Newton per coulombs. So my electric field intensity E is measured in, force is in Newton. So that's Newton per, my Q is in coulomb, Newton NC minus 1. That's the unit of my E. And my V is what? From the definition, V is called electric potential. Is the work done, and that's joules. Work done is joule. In moving a unit positive charge, charge is in coulomb, so joules per coulomb. That's the unit of my V. Very easy and simple. Once again, welcome to Mr. Bam's online class. Please don't forget to like my video, drop your positive comments, follow me on Facebook, and subscribe to my YouTube channel or on YouTube. If you have any friend, make sure you share my video to them. Thank you.